Hello atmospheric science students, Dr. Shragi, and I am ready to talking to you about writing graphics programs now. Hopefully by now you have learned how to establish an X11 connection between your client computer, your PC or your Mac or whatever, and Chesapeake. Whether that's on your Mac using the -big X flag on your SSH command, or whether that's using something like xming to establish a connection on your PC. Whatever works, we hopefully have that all worked out for you. And so it's time to start learning some of the basics of how to make graphics work in C. Now, when you are going to be making some graphics in this program, your first graphics assignment is just going to be making a picture. We're not going to worry about anything meteorological right now. Your first graphics picture then will just be something that is going to be created on a graphics window. The right term actually is a canvas. This is a canvas that we're going to have lines of C that I'm going to be providing to you that knows how to use the graphics libraries to open up a canvas. It will look something like what you see there on the window right now. It does have like minimize and maximize buttons that, depending on whether you're on a Mac or on Windows or what version of Windows you're on, it has like the minimize, maximize, close buttons, but don't use them. The way you close properly a graphics window in Unix is to click on the window someplace that you want to close and hit enter. What happens is if you actually close the window using the X or the red button or whatever is on a Mac, it shuts down the window on the client end, but actually Chesapeake is still actually keeping track of that window. Whereas if you use the enter key, that is actually launches the gclose commands that you'll be seeing in just a little bit that actually closes down the window. And Chesapeake is no longer expending computer time and memory and stuff keeping track of that window. By definition, the canvas is a unit square. It is 1 unit in the X direction and 1 unit in the Y direction. So it's a coordinate system. It's a little bit of a distorted one because the window that pops up is actually not quite square. But it's close enough for our purposes, okay? But I mean, it is in fact defined to be square. The coordinates of the corners of this are unit square. So like the bottom left corner, the origin of the canvas that you're going to be drawing on is defined to be the location 0, 0. If you wanted to put something at that location in the graphics window, you'll be at 0, 0. The top right corner rather is defined to be 1, 1. It's 1 in the X direction and 1 in the Y direction. And of course, any place in between will have some set of coordinates X, Y. There are floating point numbers. How do you actually open this graphics window so that you can start drawing things? Well, there's one more pound include that you have to include at the top of your program. Once you pound include math.h and pound included stdio.h, you need to pound include quotation marks home Shragi J packages C graphics graph.h. I know it's a pain in the butt, but you're probably only going to type that once. From here on out, all of our programs, well, I take that back. This first one, we're just making a picture. But from here on out, after that, all the programs kind of build on each other. You're first going to be making a program that makes a map. Then you're going to be plotting weather data onto the map. I mean, your next assignment will just be taking the old assignment and building on it, right? And then you'll be putting contours onto that map and so on. So, I mean, once you have this in your program one more time, you'll be fine. Okay? When you want to compile a program, you're going to use a different command than GCC. You're going to use graphcc. Graphcc is not a standard thing. That is something I made. Graphcc is actually an alias, that's like a shortcut, if you will, that I put up on Chesapeake. It's an alias for the relatively complicated set of commands that you see there on the screen. I didn't want you to have to type GCC, the name of your program, -lm, -l, x11, and then the name of the graphics library. Oh my goodness, I mean that would have just been way too much business of linking libraries. So I made this shortcut, graphcc. It types that all for you. So you graphcc, if your program's name is plot.c, then you type graphcc space plot.c to compile it. We'll see examples of this in just a little bit. Now, every graphics program has to first open a graphics canvas where you're going to be doing the drawing. And the way you're going to do that, again, the pound includes would be higher up on this window than what I'm showing right now. But the way you would do it is using this text that I have right here. You could get this out of the textbook in the current chapter. You could get this off this window, whatever. However, just put this in there literally exactly the way I have it here. This is the code that every graphics program you make for the rest of the semester is going to have. And in general, we're not going to modify it. And to be honest, a number of these things about how it actually opens the window, I don't entirely understand what's going on in the graphics libraries. For example, there's these two variables, WS type, which is an integer, actually it's 3 variables, WS type, which has to be an integer, and then two floating point numbers, XVP and YVP, that the graphics package itself needs. Okay, these are variables that the graphics package is going to be putting things in and passing between functions and so on. It might even be interesting to print the quantities that are in those variables. I've never done it, to be honest, in all these years, but they just need to be declared properly. When you actually are opening the plot, you're going to be using this gopen command, and again, this WS type equals 0. Notice that there is an argument here to gopen that is in quotation marks. That's actually going to be the title of the graphics window you open. It can be kind of interesting to put something there like, whatever, Bob's plot or something like that, or whatever, I don't know. But whatever, you don't have to put anything there. Make sure you put these, this gview command, a mistake I have made many times is to forget to put the periods in that command right there, because they are floating point numbers, but the first one has to be an integer. Again, probably just cut and paste it out of this, or whatever, just be very careful and get it to work one time. Then there's this sort of area after the gset redraw command. Again, we're not going to worry about what that is, because frankly it's not very well documented anyway. But see where that arrow is? Between there and those ghold, gclose commands, that's where you're going to put the commands that actually do drawing. Whether that's like to make a little stick figure, which is probably the kind of thing most students are going to do for the current assignment, or whether that's like all the fancy programs to read in map files and put the maps on the screen and read weather data and stuff. It'll all be where that red arrow is. Okay? And then at the end there's this ghold and gclose. Ghold actually makes it's a function that tells the program to wait until you close the window. Till you actually, because I want the canvas to stay there on the screen while we admire it. Okay? And then the user will go and put the cursor on the mouse on the window and hit enter, and then ghold will be done. And then gclose will actually do the business of closing the window. You'll notice that the graphics commands in C all start with G. That doesn't probably seem terribly surprising to you. Alright, so gclose is the one that actually closes the window. So once you have this block of code in your program, you're ready to start doing graphics commands that are going to be able to put circles and squares and lines and so on. And we'll see that the set of tools that you have here are very primitive. They're just simple things like line drawing and basic shapes like circles and rectangles and so on. And so what we're going to have to be able to do if we're going to be drawing shapes on the screen here is we're going to need to be able to tell the computer what color we mean to draw them in. We're going to need to be able to describe what we want these lines to look like how thick the line should be they be solid, should they be dashed, whatever. How to actually draw a line, how to draw shapes like filled shapes or outline shapes, and how to write text on the screen. Because those are all things at some point you're going to need to be able to do. You're going to be able to draw lines that make maps, that make outlines of states and so on. You're going to need to be able to draw shapes on the screen. You're going to need to be able to write text on the screen, like the observations at each weather station. So we need to figure out all that kind of good stuff. And first we need to understand how C Graphics thinks about color. And to understand how C Graphics thinks about color, think about an artist's palette. Okay, the actual thing that they hold in their hand while they're doing the painting. Okay, it has these little cuppies. There's a certain number of little cups around the edge of the palette, and you can put paint in there. In fact, you can put any paint in each of those cups you want. You just only have so many cups to work with. Okay, so like maybe that artist there, what has he got? He's got 8 little cups around the edge there. He can put any paint, he can mix paints, he can put any color in the rainbow, he could put no paint in them. He could put the same color in all of them. Whatever, it's totally up to the artist, but he's only got so many little cups to work with. This is kind of the metaphor I want you to be thinking about when we talk about how colors work in C Graphics, because in the same way, you have a certain number of colors you can work with, a certain number of little cups in your palette, if you will. The number is actually fairly large. It could be as high as 256, as a matter of fact. Although in practice some of them are predefined and we're not going to use them. But you have these little cups. So picture you're like an artist and you've got a palette, but it's a fairly big palette. You've got like 256 cups in here. Certainly a couple hundred anyway. And you're not going to really ever need that many cups. But each of those little cups you can put a color in. You can mix paint into those little cups. Come up with a color. Then you just say, I want to paint this in color 100. I want to color this in color 101. Draw this line in color 102, etc. Alright, the command to actually define a color is really quite interesting. It's just gcolor. Gcolor then has 4 arguments. The first is the index. the number of the cup on your palette that you're putting that color into. I'm going to give you a piece of advice. Start at 100. Okay? Your first color that you make should be color 100, then use color 101, then 102, or start at 101 if that works better for you, whatever. But here's the deal. Some of the colors that are lower numbers are predefined that the system uses. They're the colors that are being used like to create the frame of the window and stuff like that. And you don't want to try to reset that color, okay? You can get error messages, in fact, if you try to reset those colors. So start at 100 and just, you're not going to need 156 colors or whatever, how many cups you have left, okay? Then, red, green, and blue. That is the amount of red, green, and blue, shall we say, paint to mix in that cup, where it goes from 0 to 1. So if you wanted the color to be just red, put like red to be equal to 1.0, and green to be 0, and blue to be 0. If you wanted to make it something like purple, put like maybe red is 1, green is 0, and blue is 1. So you're mixing a squirt, if you will, of red and a squirt of blue, but no green. And of course it's a floating point number. You could have any number, you could have 0.5 red, or you could have 0.382875, or whatever. That's up to you. And this would then be defining colors. Now, for example, like I give you an example of a color code here, G color 100, 1.0, 1.0, 1.0 works out to white. White is full red, full green, and full blue. They're not exactly the same thing. They're web colors. They're not the same thing as like mixing paint. I don't know what you would get if you mixed red, green, and blue paint, but it wouldn't be white. But white is defined to be all the red light, all the green light, and all the blue light. If you want black as one of your colors, like in this case I defined color 101 to be black. I put no red, no green, and no blue in there, so it is black. And in fact, there's all kinds of common colors like this. You can see on this table here how red, green, blue, yellow, purple, cyan, gray, all kinds of colors like that work. In fact, I have another table here that's some less common colors you might find interesting, like orange, magenta, brown, gold, light green, whatever. There is no shortage of utilities on the web to help you find colors, and you can just experiment with them. It's actually kind of a fun thing. The limit is just your imagination as to what color values to put in there, but you only have so many to work with, right? There's only 256 possible colors, and some of them are already on use. I'm sorry, only 256 possible palettes for the C graphics to work with, cups, if you will. Don't ever use more than a few, okay? We're not in the class to do it, it's just too wild and crazy. Okay, so you have this idea now, you can define a color. When you're ready to draw or paint, the metaphor gets a little bit mixed here because, you don't draw by dipping your pencil in these paints, but you get the idea, right? We can pick up the color we want. You can pick up a pen. The question then is, you need to decide not only what the attribute of the color is, but like how wide is the line that you're going to be drawing? Is it solid? Is it dashed? Is it dotted? Etc. Well then, in order to do that, before you start drawing lines, you need to set the attributes of the line that you're going to be drawing. And that is done using a command called gline_attr for gline attributes. And you set the color, the width, and the style. Actually, it's color, style, width there. Color is just going to be the number of the cup that you're picking from your palette. So if color 100 is defined in your palette to be white, and you want this to be a white line, set color, gline_attr 100, comma, then the style. Style is an integer from 1, 2, 3, 4, 5, 99 times out of 100 you want 1. 1 is line style solid. Okay, it's kind of fun though to experiment with some of the other ones. There's like long dashes for number 1, 2, short dashes for number 3, 4 is dash dots, and 5 is dots. It can be kind of fun to experiment with some of these, but they're not terribly practical for like you're not going to draw contours in long dashed lines or something in this semester. So but if you want to experiment with them in this assignment, that's actually kind of fun. Most of the time though, that style parameter just is 1 because you want to draw solid lines. And finally, the last attribute there is going to be a width. It's going to be a floating point number that describes the width of the line. I have it written here in terms of pixels. Not 100% sure that's right, but it might be points or something like that. Whatever. It's some attribute. 1 is a thin line. I think you can't use thinner than 1. But if you make it the number bigger, you get a fatter line, and we'll see. But unless you're trying to do something clever, most of the time you want 1. But you'll see that there's interesting possibilities here. So once you have set all these line attributes, they stay that way, okay, until you change the settings. Once you have decided, I'm going to be drawing with blue, a 1 point thick line that's solid, and so I've got I picture in my mind, I have set the attributes, I'm picking up blue, solid, 1 point thick line, then I can start drawing lines. We're going to have something called the G-line command. And if I draw another line, and another line, and another line, they're all blue, solid, 1 point lines. And until I use a new G-line ATTR command to set the the attributes of the line again, all of those lines are going to stay that way. Well, they're going to stay that way no matter what. So then, let's say after I've drawn some lines in blue, 1 point solid, I say instead, now I'm changing my attributes. I have a new G-line ATTR command that's going to say silver, 5 point line solid. It's like you're picking up a different pen, and now I'm drawing shapes. The shapes I draw now are in those new attributes. It's like I've set down that other pen and I've picked up this one. Okay, you understand? You don't have to set G-line ATTR every time. In fact, that's not the idea at all. You set it, and then you draw line segments, and then you put that pen down and you pick up the next one to do the next line segments. We'll see some examples of this in just a little bit. So once you've defined some line attributes, you can start drawing lines with those attributes. So like, for example, if I want to draw a line from there to there, from some location on the screen, x1, y1, to some other location on the screen, x2, y2, recognizing that we're in a unit square here, so we're talking about, you know, x1, y1 would both be within the range 0 to 1, and same with x2, y2. The command to do that is very simple. It's just G-line, x1, y1, x2, y2. Pretty straightforward, right? You just define that like that. Now, it does not hurt anything if x1 and y1 are, that point, that is an endpoint, is outside of your unit square. Doesn't hurt anything if x2, y2 is a point that's outside of your unit square. Only the part of the line segment that actually shows up in the unit square is going to be drawn. We can experiment with this in a little bit when I go to the text, and we actually use it a little bit. Only the part that's actually inside of that drawing canvas, the unit square, will get drawn, but there's no harm in letting one or both of those endpoints be outside of the range. In fact, that will happen a lot. There's other commands. There's a filled rectangle command. Now to draw a filled rectangle, you need to know the coordinates, x1, y1, and x2, y2 of two opposite corners. And the command is gfrect for graphics filled rectangle, x1, y1, x2, y2. That's no problem. But before you draw that rectangle, you actually do have to set the attributes of the rectangle. What color is it going to be and how is it going to be filled? Gfill ATTR is what you use there. You give it a color, like maybe I decided that 102 is yellow. Alright, then I'll set color, I'll put, you know, Gfill ATTR 102, comma. Now, 99 times out of 100, you're going to choose 0 for your other attribute. The other attribute there is, it means solid. 0 means it's filled with a solid color. But actually, it's fun to experiment with the other ones. Like, you know, go ahead and try it and run it again, drawing rectangles using, instead of a 0 there, use a 1. It's different fill patterns, like cross hatches and stipples and things like that. It's actually kind of fun. But in this class, you're really only going to ever need the 0 right there. By the way, see how there's a gfrect for graphics filled rectangle to draw the rectangle? There's also a grect if you want an unfilled rectangle. If you just want the line, then you would just use grect. Once you have used the gfill ATTR attributes, you actually could do other ones. Like, for example, there's a gf circle, where you give it the x and y coordinates of the center of the circle and the radius of the circle, and it'll draw a circle for you. If it's gf circle, it's a filled circle that you have defined using attributes from the gfill ATTR command that we just saw for rectangles. Or you could just use gcircle, and it would draw an unfilled circle where you just get the line on the outside. Same with, there's actually a gf ellipse that's a filled ellipse. X1, Y1, and X2, Y2, I believe, are the corners of the rectangle that bounds the ellipse, so it's a little bit awkward. I would have done it differently. I would have probably made them the foci of the ellipse or something like that, but whatever. So like if you want to make an ellipse, just think about it as a rectangle that frames that and give the coordinates of the opposite corners. Again, you have a GF ellipse that would pick up the attributes from a gfill ATTR command, but if you wanted it to be an unfilled ellipse, you would just drop the F on there. How about text? Man, there are going to be lots of times that we're going to want to put text on the window. Like we're going to want to put some kind of label or whatever. Hold on just a second. Sorry, my laptop here got unplugged somehow, just uncharged, lost the charge. Okay, so there's going to be lots of times this semester where we're putting text on the screen, like we're going to plot the data for weather stations and so on. Before you can, okay, you can see the sequence of commands here. There's the text attributes, there's how the text will be aligned on the screen, and there's going to be the actual business of printing the text onto the screen, which is this cool PrintF command. I like PrintF, it sounds cool. Okay, first, the text attributes. You're going to have to describe how you want the font to work. Now, I don't have multiple fonts installed on the computer at Chesapeake, for C graphics anyway. So they're all in this sort of Helvetica, it's actually Modern is the name of the font. First, you're going to describe the color. Then you're going to describe the height of the font. Height of the font is in terms of the unit square. If you think you're going to put an 18-point font on the screen there, that's not going to work. I mean, if you put an 18 there, it's going to think that your letters should be 18 times as high as the unit square. Oh my word, they'll be huge. Everybody makes that mistake at some point. No, I mean, you're going to want numbers in here like 0.1, maybe even smaller, 0.05 or something. So you're describing them in terms of the unit square. How tall are they compared to the unit square? The width is actually the thickness of the lines of the font. Okay, because you might want the lines to be bolder, or you might want them to be thinner. Generally, you're going to want them to be 1. Expand is actually the distortion of the font. It like you can make the font narrower, or you can make the letters really wide. Not the most important thing. Most of the time, just use 1. Now, before you can draw, you also have to explain, you're going to be giving, look at the PrintF command right there, you're going to give it the coordinate x, y, and then you're going to print something at x, y. The question is, what is that x, y? Is that the beginning of the letters? Is that the end of the letters? Is that the center of the letters? GText-Align explains that 99 times out of 100 what you mean is 2, 3 here. Where 2, 3, we'll see in a little bit, means your text is centered at this location. Like if X, Y is the location on the map of like a weather station, you want whatever weather data you're plotting to be right there on top of that station, centered right there on that city. So 2, 3 is what you need. There's actually this nifty little graphic I found that explains it here. In each of these locations here, X is, that little red X is showing what was the location given to by the gprintf command. And then, okay, well, different alignment schemes. Like, see how 2, 3 means that whatever that point was, that's like the center of what we just printed. Alignment 2, 3 sort of spans right on top of there. That's in contrast to some of these other ones, which can be useful for like putting labels on the top of the graph or something like that. But for pretty much everything we would be doing here, your GText alignment should be 2, 3. But it's kind of fun to experiment with some of the other ones to get the results that you want. Alright, then you just use this gprintf command, which works just like a printf statement. For example, you could gprintf at the location 0.5, 0.5, in other words, the very middle of the screen. This is the middle. I actually put a slash in there, I don't know why I did. That doesn't really make sense on the GText screen. Or, for example, you could print at 0.5, 0.5, you could print in like floating point 4.1f, the temperature. Okay, where like, from an earlier part of your program, you actually had set temperature is equal to, or used a function, or read it from a file, or whatever, and now you're printing it at that location on screen. This is exactly what we're going to be doing when we're doing weather maps and so on in just a few short weeks. So in your assignment, you're going to be producing a graphics window with a picture of anything you want. I really don't care. It doesn't have to be weather related or whatever. Your image needs to contain, and I put some list of stuff here. I'm not going to literally be sitting there counting if you have 10 lines or whatever. I want you to draw me a picture, okay? I mean, whatever works to make it actually do, and some text and so on. Let's actually do a little demonstration here. All right, I'm over here logged in as student 315, and I've been working on a program that I'm calling assignment 10.c. If you look at assignment 10.c, notice it's got the pound includes math.h and stdio.h, and then it also has this new one about from my home directory in the packages C graphics graph.h. Here's that stuff that has to be in there to open up a graphics window. And again, I literally just cut and paste this from another program that I had. I mean, I'm not going to sit there and try to remember all this, and I don't expect you to either. But by the time I get down with this gset redraw, a drawing canvas is now open on the screen. It's a black unit square. Next, I'm going to define some colors. Here I define color 101 to be white, so G color 101. 1, comma, 1, comma, 1. I define color 102 in this example to be red. So here's G color 102, and I set it to be 1, comma, 0, comma, 0. All red, no green, no blue. Alright, so then I'm just going to do some examples of showing you how lines work. Here I said G-line ETTR. I'm setting up to use a white pen. Remember, color 101 is white. The 1 here means that it's a solid line, and the 1.0 means that it is 1 point thick on the screen. And I just drew a line from one coordinate x1, y1 to another coordinate x2, y2. And we'll see what this looks like on the screen in just a few moments. I then pick up a red pen and draw a line. So I change the attributes to red, solid, thin, 1.0 thickness line. I just drew another line segment. Okay, I'm not making a picture or anything, I'm just drawing some line segments. Then I picked up a white pen again, and I'm by the G-line ATTR command, but this time I set the thickness to be 10 points wide. Okay, and I just drew another line. And then I want to show you, without another G-line ATTR command, in other words, I still have a white, thick line attribute, I drew a bunch more line segments, 4 more. Okay? Then I have the G hold and the G close, and we're done. Look what this actually does. If I compile it using that graphcc assignment 10.c command, and run it, look what I get for the output. Here's my thin white line. Here was my thin red line. Here's my fat white line, and then I didn't change the attributes of the line before I drew 1, 2, 3, 4 more line segments around the edge of the box. Cool. Alright, to close this window, I go over here and press enter on there, and go back in here into assignment 10.c, and I can do something else here, like, what else do I want to do? Let's change some of these attributes. Let's say that this white line that we drew originally, let's change its attributes to 2. Okay, 1 was solid, 2 will be long dashed, if I remember right. So I'm going to recompile it and run it. Yep, it's a dashed line now. Okay, close that up. What else do we want to try here? We could have made a different color. I'm going to go ahead and put this back to solid line. What if I changed color 101, instead of being white, let me call that yellow. Okay, I know other places I'm calling it white, but whatever. Yellow is all red, all green, no blue. So 1, comma 1, comma 0 is yellow. And if I compile it and run it, now those lines that are picked using color 101 are yellow. Okay. C Graphics doesn't know anything about animation. C Graphics doesn't know anything about how to save these images. That's not entirely true. There is a way we could make this so that it could actually save them as GIF images or something, but we're not going to do that. We're just practicing drawing right now, okay? Yeah, but then a handful of tools, like drawing line segments. Later I'm going to be showing you how to get a map file that contains a whole bunch of coordinates that describe the little line segments that make up, say, the boundaries of states. And you're going to read through that file, picking up each of the little, x1, y1s and x2, y2s that make up each of the coordinates that describes the shape of each state. And you just draw lots of little line segments in a loop there, right? You're going to draw all the little line segments that make up Nebraska and all the little line segments that make up the boundaries of Iowa and so on. And you're going to have a map. But for now, just have fun. Just go ahead and make a fun picture using these graphics commands, okay? Alright, this is going to be a fun assignment. I always look forward to seeing what you guys come up with. Please let me know if you have any questions. This has been Dr. John Schrage.